In this video, we're going to look at estimating effect sizes from a fitted model. So we're going to look at data from the wolf.csv file, and this gives logged cortisol values, which we're going to use a response variable against the three different populations, which we're going to use as our explanatory variable. We want to know, first of all, is there on average a difference in log cortisol values across the three populations? So we've done null hypothesis testing, and here in the bottom left is the output from that, and the overall p-value for the comparison is below our critical 5%. So yes, we have evidence to reject the null hypothesis and say that there are some differences in the average log cortisol values between the three populations. The next question is, what are those differences? And that's saying, what is the estimated effect size? So one way to do that is to look at a summary of the fitted model. And the relevant part of the output is the coefficients tab here. And the first line of this output is called the intercept, and this is giving the estimated log cortisol for population 1. So the estimate is 2.65, and the standard error on that estimate, the uncertainty, is 0.06. The second line, this is our first estimated effect size. It is how population 2 differs from population 1. So population 2 has a log cortisol value of 0.14 higher than population 1, and the estimated uncertainty on that difference is 0.07. And then finally the second estimated effect size, which is the difference between population 3 and population 1, is 0.33, and the estimated standard error on that is 0.09. There's a second way to report the uncertainties. Rather than using standard errors, we might want to report 95% confidence intervals. And we can use the confint command on the fitted model to produce those intervals. So confint produces 3 rows, which correspond to the 3 rows from the summary output that we've been looking at. So the first row gives the 95% confidence interval for the estimated log cortisol from population 1. And then the second row gives the 95% confidence interval for the difference between population 2 and population 1, and the final row here gives the 95% confidence interval for the estimated difference between population 3 and population 1. So in the next video we're going to look at using the EM means package as another way to estimate effect sizes.